हेलो फ्रेंड्स, वेलकम टू द गेट अप्रोच। आज हम करेंगे एमएफटी के सबसे इम्पोर्टेंट चैप्टर, दैट इज़ प्लेन वेव्स। इसके कॉन्सेप्ट हम बहुत ही शॉर्ट में पढ़ेंगे, परंतु आपको सब कुछ समझ आ जाएगा इन्हीं कुछ मिनटों में। तो हम बढ़ते हैं आगे। तो हम पहले बता देते हैं आपको कौन कौन से टॉपिक्स इसमें कवर होने वाले हैं। पहले तो आएगा मैक्सवेल इक्वेशन, जो कोर इक्वेशन होता है किसी भी इलेक्ट्रॉनिक चैप्टर का। और उसके बाद कवर करेंगे हम उसी में से derived, yeah, if you can say, how the equations work with the materials. So हम उनमें से कुछ कांस्टेंट्स निकालेंगे। अब उन कांस्टेंट से हम कुछ पैरामीटर्स बनाएंगे। उन पैरामीटर्स का हम यूज़ करेंगे टू फाइंड आउट द ओरिएंटेशन, दैट इज़ पोलराइजेशन ऑफ द वेव्स। और उससे हम उसकी पावर निकालेंगे थ्रू पॉइंटिंग वेक्टर। एंड देन we will be using Snell's law and Bruce triangle when there will be two mediums. And after that it will be like the boundary conditions, one of the most important topic. Okay, now first let's do the Maxwell equations. तो पहले मैक्सवेल इक्वेशन देख के तो आप लोगों को पहले ही डर लग जाता है। डेल डॉट डी इक्वल टू रो वी, डेल डॉट बी इक्वल टू जीरो, डेल क्रॉस ई इक्वल टू माइनस डी बी बाई डी टी, एंड डेल क्रॉस एच इक्वल टू जे सी प्लस डी डी बाई डी टी. So this is not anything to be fearing. Actually the problem is that that we think that it's a new concept. It's not a new concept. It's like the concept we have learned during our 8th and ninth or 10th basically. Let me show you how. See, uh, if the first equation says that del dot d equal to rho v. So what does that mean? That here the del dot operator has some importance. Del dot operator always says that whatever is connected with it, like del dot d, so it will be like showing the outflow of 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 the vector d. So means whatever it is connected with, it will be showing the outflow of that, like outflow or inflow, whatever you can say. Like and that outflow will be equal to the charge density of that of that substance. All right. And for example, how can we explain it with more simply? Simplicity is like this. Suppose you have some water, okay, in a beaker, and if you put something in it, if you increase put something in it, there will be some outflow of water. uh, if the beam is totally filled, so that outflow of water is directly proportional. Basically it is not directly proportional. The thing is that it is directly equal to the substance that we put in it. So the substance will be the charge and the flow will be the electric field density here. So it's like just in Archimedes principle, as you had read in 8th or 9th class. If you put something in the water, there will be some outflow of the same volume of water. So it is like that. If you put a charge, there will be some outflow in the form of what? In the form of the electric field density. But when we come to magnetic field, why does not happen? Because it doesn't happen as the magnetic field B don't have any particular single, like the electric charge have positive or negative. The electric field don't have their monopole. Like if we cut a bar magnet into half, then again we will be getting two poles only. We can't get any pole, and if you find any pole single, please tell me. But it's till then this formula is going to be valid. That if we apply this principle to the beaker, then if we are not putting anything in the beaker, then how can be their outflow? So outflow will be zero. So del dot b will be equal to zero. Okay, now the third equation is like the Faraday equation. And as we had read in ninth class, that minus dB by dt is like change of magnetic field. And if we take a bar magnet near an electric current like that, so they will be near a wire, so there will be a change in the electric field of the wire. So the equation is saying like that the change in magnetic field will lead to production of electric field and forming of curls of electric field. All right, now coming to the fourth equation, that is the equation uh, which is also like the Faraday's law only, but we call it Ampere's circuital law, in which the magnetic field produced is equal directly proportional to the electric current. So here the magnetic field is equal to the electric current. And what is this new thing, dd plus d by dt? This is the new thing that Maxwell had added into the Ampere's circuital law. And this can be formed by, you have seen that in case of check capacitor there is a distance between the two plates, then also current flows. So what is that current? That current is this current, displacement current. So how can we prove its existence? See, we know that del cross H is equal to 0. All right. So if we apply the, sorry, so guys, is it going on?